So let's now find the inverse for letter C here. All right, so I will copy that down. And then we'll go through our steps. So first step, we want to change our f of x into y. So this will be y equals all of this. Next, we want to switch our x's and our y's. And then we want to solve this for y. Now remember, we need to get rid of this fraction, and in order to do that, we're going to multiply by that denominator, y plus 2, on both sides. On this side, the y plus 2's will cancel out. Over here, I need to distribute this x through the parentheses. So x times y is xy, and x times 2 is 2x. And then over on the right, I now just have y minus 1. All right, now let's remember we're solving for y, so we need to get y's on one side and non-y's on the other side. So I'm going to move this y over to the left. I'll leave the xy, so it'll become a negative y when it goes across the equal sign. And then my 2x needs to go over the right since it doesn't contain a y. It will become negative, and I still have the minus 1. All right, now we've got this strange situation going on over here, and there is that trick. We want to think of this as a 1y, and let's factor out y. And when we factor y out, we'll have an x right here and a minus 1 right here. And now that we have y out in front, we can take this stuff that is being multiplied by y and divide it out. So divide out the entire quantity x minus 1. And now we have our inverse. F inverse of x is equal to negative 2x minus 1 over x minus 1. All right, now let's do that last inverse. So let's see, it was x cubed minus 27. All right, so let's first change the f of x to y. Let's switch our x's and y's. Oop, that's a weird looking y. Now let's solve this for y. Let's add 27 on both sides, of course. And we get x plus 27 equals y to the third. Now we still want to get rid of our cube power that's on our y. So recall to get rid of, just like we got rid of a square by doing the square root, we'll do a cube root to get rid of the cube. And of course, the cube root and the cube will cancel, and we'll have y by itself. And I'll go ahead now and just write it in the F inverse notation. We always want that in the front and not the back. All right, now let's go to our next one. We want to verify that 3x plus 5 and x minus 5 over 3 are inverses. Now, we could go through the same process we've been going through for number 11, But instead, what we should do when we're verifying that they're inverses is compose them together and see if the answer is x. And that is the very definition of inverses, is that when we compose them together, we get x. So let's start by putting parentheses into the first one. Let's drop g into those parentheses. Now let's notice immediately the 3's will cancel. And then we have x minus 5 plus 5. And of course, the 5's cancel. And we get x, exactly what we expected. Now when we verify it, we have to go in both directions. So we also have to do g composed with f. All right, so g, let's put parentheses into it. So we're going to have parentheses minus 5 over 3. All right, let's drop f into those parentheses. F is 3x plus 5. Now we just used the parentheses to tell us where to drop things. Let's notice that there's nothing in front of them, so they're not necessary. So immediately the 5 and the minus 5 can cancel out. And of course, that leaves us 3x over 3. And the 3's cancel, and we get just x. So they are, in fact, inverses. All right, now let's look at this last one, number 13. Graph f of x equals 4x plus 1 and its inverse. All right, well, let's bring that down here. Y equals 4x plus 1. All right, well, let's graph this thing. And of course, this will not be perfect the way I draw on here. All right, so we have, let's notice this is y equals mx plus b form. So we have a y-intercept of 1. So there's our first point. And then our slope is 4 over 1. So let's go up 4 and over 1. One, two, three, 4, and over 1 puts me right there. So let's draw that line. I'm going to erase that. See if I can do a little bit better. Well, I'm still missing my point. All right. Okay, now let's draw the inverse. We have 2 points right there that we can plainly see. There's this one, which I missed, and that's really 1, 5. And then we have this one, which is 0, 1. And we know that our inverse has the reverse of those. So let's see, 1, 0 would be right here. And actually, let me give it a different color for the inverse. So 1, 0. And then this one would be 5, 1. Which will be right here. And our inverse is going to be a line also. So let's just, well, goodness. My ability to draw a straight line on here is just pretty pitiful. So it's going to look something like this. Although it should be straighter, of course. All right, so now I still have a little bit of time left on this video, so let's go back to the review. Oops, sorry, not that. And let's graph the inverse of the function shown below that is on our review sheet. All right, so number 14, and this is a little bit hard to see on here, but there is the point 5, negative 3. So down here, I want 3, I'm sorry, that's 5, positive 3. I want 3, 5, And 3, 5 will be an open circle. I think that's about right there. And then this one is 2, 1, so down here will be 1, 2. And then this one here is -2, -4, so I want -4, -2, there. And then, let's see, we've got, looks like -5, -5, so that one's going to stay the same, -5, -5. And I think maybe this is my -5, yeah. And then we, of course, will connect those. Hopefully on the test you will be straighter than I am on here. And we've got our inverse. All right, let's see what the next ones are. Yeah, let's go ahead and do a few of these since I have a little bit of time left on the video. All right, now let's remember, if we have no fraction and no square root, the domain is all real numbers. So the first one is easy. Its domain is -infinity to +infinity. Any polynomial has domain, all real numbers. For a square root, we can't have a negative underneath the radical. So we want to make sure that what's underneath that square root is either positive or 0. So we solve the inequality. 2x minus 4 is greater than or equal to 0. So let's do that. Let's add 4 to both sides. And we get 2x is greater than or equal to 4. Divide out. Now that's not going to change our inequality because it's a positive. So we get x is greater than or equal to 2. Let's write that in interval notation. That is 2 to infinity. All right, now let's look at C. C, we have a fraction. And remember, we're not allowed to have 0 in the denominator of a fraction. So let's set the bottom to 0 and see what will cause us to have 0 in the bottom of that fraction. So we'll have x squared plus 5x plus 6 equals 0. That factors. Let's notice factors of 6 that add to 5 are 2 and 3. Set those to 0. And solve them. And we get -2 and -3. Now let's remember these are the two things we cannot have because they cause the bottom to be 0. So our domain is x is not -2 and x is not -3.